September 26th, 2022, 7 million miles away from Earth. Something happened that had never happened before in the entire history of the solar system. For the first time in 4.6 billion years, an intelligent species deliberately changed the motion of a celestial object. Not by accident, on purpose. A spacecraft built by humans slammed into an asteroid at 14,000 miles per hour. And in that moment, humanity proved something extraordinary. We might finally have the ability to defend our planet from an asteroid impact. But the most surprising discovery didn't happen during the collision. It happened years later when scientists studied the final images from the mission, because those images revealed something about asteroids that no one had ever seen before. The mission was called DART, the Double Asteroid Redirection Test. It was designed by NASA as a simple but powerful experiment. The goal was straightforward: crash a spacecraft into an asteroid and see if the impact could change its orbit. No nuclear explosions, no science fiction technology, just physics. Momentum. The target asteroid was called Dimorphos. Dimorphos isn't very large. It's only about 160 meters across, roughly the size of a football stadium. And it orbits a larger asteroid named Dimorphos, forming a tiny two-body system drifting through space. Scientists chose this system carefully because Dimorphos posed no danger to Earth, making it the perfect test subject for an experiment in planetary defense. On September 26, 2022, the DART spacecraft reached its destination. Traveling at nearly 23,000 kilometers per hour, it slammed directly into Dimorphos. The energy released in the collision was roughly equal to 3 tons of TNT. But what happened next surprised scientists around the world. Instead of simply absorbing the impact, the asteroid blasted a massive cloud of rock and dust into space. Scientists call this material ejecta, and that debris acted like a natural rocket engine. As the material shot outward, it pushed the asteroid in the opposite direction, amplifying the effect of the collision. Imagine releasing air from a balloon. The air rushes out one way. The balloon shoots the other way. The same thing happened here, except the balloon was an asteroid floating millions of miles away. The results were far beyond what anyone expected. Before the mission, scientists predicted that changing the asteroid's orbit by 73 seconds would count as a success, just over a minute. Instead, DART shortened the orbit of Dimorphos by 32 minutes. 32 minutes. Humanity had just completed the first successful asteroid deflection experiment in history. But the story didn't end with the impact. Years later, scientists began carefully studying the final images captured by the spacecraft before the collision. And in 2026, they noticed something strange. Faint streaks across the surface of Dimorphos. At first, researchers assumed something had gone wrong. Maybe the camera malfunctioned. Maybe the image processing software had introduced artifacts. But after repeated analysis, the marks remained. They were real, and they revealed something scientists had never directly observed before. Tiny fragments of rock were slowly drifting from Didymos to Dimorphos. Scientists nicknamed them cosmic snowballs. These particles had likely been thrown off the larger asteroid when sunlight gradually spun it faster and faster over time. Eventually, pieces of rock broke free, and some of them drifted through space until they landed on Dimorphos. This discovery changed the way scientists think about asteroid systems. Instead of being static objects, asteroids can actually exchange material with each other. They evolve, they interact, they change. In other words, asteroid systems are far more dynamic than we once believed. The impact also revealed something important about the asteroid itself. Dimorphos isn't solid rock. Instead, it's what scientists call a rubble-pile asteroid, a loose collection of boulders, dust, and debris held together only by gravity. Think of it less like a solid mountain and more like a floating pile of cosmic gravel. Because of this fragile structure, the collision didn't just change the asteroid's orbit, it changed its shape. Before the impact, Dimorphos had a relatively symmetrical structure. After the collision, the asteroid became more irregular and elongated. Humanity hadn't just nudged an asteroid, we had reshaped it. All of this might sound like an impressive scientific experiment, but the real reason this mission matters is much bigger. Our solar system is full of asteroids. Some of them cross Earth's orbit. Scientists estimate that tens of thousands of near-Earth asteroids larger than 140 meters exist. Objects large enough to destroy entire regions if they struck our planet. One of the most famous is 99,942 Apophis. In April 2029, Apophis will pass extremely close to Earth, only about 31,000 kilometers away. That's closer than many satellites orbiting our planet. For billions of people across Europe, Africa, and parts of Asia, the asteroid may even be visible with the naked eye. Imagine stepping outside and looking up at the night sky and seeing a massive asteroid racing past Earth. Moments like that remind us of something important. Space may seem empty, but it isn't that it's filled with debris left over from the birth of the solar system. And some of those objects cross our path. And if you enjoy exploring discoveries like this, the science behind black holes, asteroids, and the mysteries of the universe, consider subscribing. Because the deeper we explore space, the more incredible the story becomes. Fortunately, the DART mission proves something remarkable. Humanity is no longer powerless. For a cost of about $330 million, less than the budget of many Hollywood movies, scientists demonstrated that we can change the path of an asteroid. Telescopes on Earth watched the debris plume from the impact for months. For nearly 2 weeks, the asteroid even developed a temporary comet-like tail. The experiment worked better than anyone expected, and the mission is only the beginning. Future missions will study the asteroid system in greater detail. Each new discovery will help scientists refine the technologies that could one day protect Earth from a real cosmic threat. The dinosaurs never had that chance. They couldn't see the asteroid coming. They couldn't stop it. But humanity can. On September 26, 2022, our species proved something extraordinary. For the first time in history, we reached out and changed the motion of a world in space. And somewhere out there tonight, an asteroid is traveling on a slightly different path through the solar system. Because we put it there, we're no longer just passengers on Spaceship Earth. We're its crew, and for the first time, we are beginning to learn how to steer.